In 2025, the European Union launched a groundbreaking project called Destination Earth, or Destiny, aiming to create a highly detailed digital twin of our planet. Powered by artificial intelligence, supercomputers, and real-time satellite data, this model simulates Earth's systems in high resolution, even down to the level of a single square kilometer. These models are not just for science fiction, they have real-world uses. Governments and emergency agencies can use them to predict floods, track extreme weather, and assess the impact of climate change before it happens. The data allows faster and more accurate decision-making, potentially saving lives and reducing damage. One of the core components of Destiny is the use of AI to constantly refine simulations. As new satellite imagery and IoT data come in, the system learns and adjusts. This makes climate predictions more precise and helps cities plan for future risks like heat waves or rising sea levels. Meanwhile, DeepMind has introduced Alpha Earth, a virtual satellite that creates global maps using AI. It highlights land use, ecosystems, and infrastructure. This helps planners locate optimal sites for renewable energy or climate-resilient housing. Alpha Earth is trained using thousands of geospatial datasets and deep learning techniques that mimic how humans interpret satellite images, which significantly boosts the accuracy of environmental assessments. NVIDIA, known for its AI chips, has developed Climate in a Bottle, or C-Bottle. It simulates weather events like rainfall or heat waves with much higher detail than traditional climate models. With data as fine as 5 kilometers, AI helps visualize short-term climate events in ways never seen before. C-Bottle also enables scenario modeling. Governments and researchers can ask what-if questions, such as what might happen to coastal cities if sea levels rise 2 meters in the next 30 years. These technologies are helping close the gap between climate science and action. For example, city planners in the Netherlands have started using Destiny's simulations to redesign infrastructure, placing drainage systems and green roofs in high-risk flood zones. In Bangladesh, a country frequently hit by cyclones, NGOs are working with local governments to implement community-based alert systems linked to AI-driven weather models. But not everyone is convinced. Experts warn that relying on AI simulations can be risky if not properly verified. Policymakers might act on predictions that are too narrow or flawed. Ethical concerns also arise around who controls these systems and how the data is used. Without transparency and inclusive governance, digital twins could deepen existing inequalities. There are also environmental costs. Training large AI models consumes enormous electricity and water. For instance, one estimate found that training a single AI climate model could emit as much carbon as 5 cars do in their lifetime. In the push to save the planet, some worry AI might unintentionally strain it further. Despite the concerns, the momentum is growing. Economists estimate that AI tools could reduce global greenhouse gas emissions by up to 25% in sectors like energy, agriculture, and transportation by 2035. Innovations like precision irrigation, AI-driven crop monitoring, and intelligent energy grids are already being tested in pilot projects across Asia and Africa. The private sector is also taking note. Tech giants like Microsoft and Amazon have invested heavily in climate tech startups, while insurance companies are partnering with data firms to refine risk models using AI. These partnerships aim to make climate data more actionable and accessible, not just for scientists, but for businesses and communities. Education is another area seeing transformation. Universities and online platforms are using digital twin technologies to teach climate science in immersive ways. Imagine a high school student putting on a VR headset and exploring a melting glacier or simulating the impact of deforestation on rainfall patterns. In the end, digital Earth models are becoming essential tools in humanity's response to climate change. They're not magic solutions, but they might be our best bet for seeing what's coming and preparing wisely. The question now is not whether to use them, but how to do so responsibly, equitably, and with a long-term vision.